Quadratic functions, graphing. Use the following information to graph a quadratic function, and we call that a parabola, right? So we're going to use the vertex, we're going to use the axis of symmetry, the y-intercept. I'm not going to use x-intercepts unless I have to, since there may not be any. And then we're going to determine if a is positive, greater than 0, or negative, less than 0. And then we're going to use that to determine if the parabola opens up, it's smiling, and that's if a is positive, or if it opens down, it's frowning if a is negative. So technically it opens up or down. I will often say smiling or frowning. All right, so positive A smiles, negative A frowns. Just like if you're positive, you may be smiling. If you're negative, having a bad day, you might be frowning. So here, let's find the information and graph the following quadratic function. So we'll do a few of these, and we'll find the information, and as we find it, we will put it over here on the grid and graph it. So for the axis of symmetry, when it's in this form, A equals 1, B equals -4, and C equals 1. So 1, -4, and 1 for the A, B, and C. So for the axis of symmetry, x equals -b over 2a. So x equals negative of -4 over 2 times 1. So x equals 2 negatives make a positive, so 4 over 2. So x equals 2. So x equals 2. 2 is the vertex. The 2 is the x value of the vertex, I should say. 2 is not the vertex. And the axis of symmetry is x equals 2. So that is this dotted line right here on x equals 2. So somewhere on that dotted line, there's a vertex, because that's the x value. And how do we find it? We're going to find it by finding k of that value, k of 2. All right, so k of 2 is going to be 2 squared minus 4 times 2 plus 1. So it's going to be 4 minus 8. Again, that's its own term, so you can go ahead and multiply the -4 times the 2 plus 1. 4 minus 8 is -4 plus 1, which is -3. So 2, -3 is the vertex. So you have 2 and then 1, 2, 3, down 3 right there. There is your vertex, okay? There is your vertex. So what about the y-intercept? Well, let's just keep going here, find this out. The y-intercept is let x equal 0. When it's in this form, if you recall, it is 0, c. Okay? We know c is 1. You could also plug it in. 0 squared minus 4 times 0 plus 1. You get 0 minus 0 plus 1, right? You get 1. So you could do all that work, but it's 0, c when it's in this form. So 0, 1. 0, 1 is the vertex. There it is. Okay? On the y-axis at 1. And then is this thing smiling, frowning? What's it doing? Is A positive, negative? What is it? So A is equal to 1, which we know is greater than 0. So I'm going to put greater than 0 right there. I just want a greater than or less than symbol right there in that box. That's what I want, okay? So then what is it doing if it's greater than 0? It is smiling. It opens up. But you really don't even need to know that. If you look here at the vertex and here at the intercept, and you know the basic shape is either a smile or a frown, how could it frown and still go through this point? It can't. So it's got to go this way. Now, this is going to be a little tough because it's kind of narrow on this, but this thing is going to kind of go up through here, and then it's going to do the same thing over here and go up through here and look like that. Notice I put arrows on the end of it. I tried to make it look like a mirror image of each other. There's a couple things I don't want if you're in my class. I don't want a V. All right, don't give me a V. Don't curl it out either. Don't curl it out like that. And then the other thing is curling it back over itself. You got this thing here. That would fail the vertical line test, okay? So don't go doing that, all right? So that's the main thing. I mean, if it goes barely back over it, like if you're doing this and it kind of curls back over itself, I don't like that right there, okay? So don't do that. Make sure it keeps getting wider, but don't do this and curl it out like some kind of cursive V or something, all right? So there's the sketch of the graph. So here's another one. What is A? What is B? What is C? A is -1, B is 6, and C is -5. So x equals -b over 2a. X equals negative, and b is 6 over 2 times -1. So again, I have two negatives here. So 6 over 2, and it's positive. Two negatives make a positive when you're multiplying and dividing. So x equals 3. That's my axis of symmetry. So my vertex has a 3 for the x. So I go to x is 3, and oops, I missed that. I just missed that badly. and there's my dotted line for my axis of symmetry. And again, I missed that. Let me try to fix this right here. Fix this one. There we go. Move it over a little bit. All right, and then I need to find my y value of this. It's going to be k of 3, which is going to be a negative, let me fix that, a negative 3 squared plus 6 times 3 minus 5. And that negative is out front. When you have this here, you are only squaring the x. You are not squaring the negative and the x. If you wanted to square the negative and the x, it would look like that. Okay, so there the negative is out front, you're squaring the x, and if the x is negative, you put it in parentheses with a negative, and then the negative is still out front. All right, you don't change the sign first. You got to square it first and then multiply by the negative, right? Order of operations, power, then multiply. So here, you're going to do the 3 squared with the negative out front, so that's negative 9, and then here multiply that plus 18, because that's its own term. So then, however you want to do this, negative 9 plus 18 is 9 minus 5, and that's going to be what? 4. So 3 comma 4 is the vertex. 1, 2, 3, 4. There it is. Okay. And then what about the y-intercept? Well, let's just keep going here. Y-intercept. The y-intercept is 0 for the x. And in this case, again, remember it's 0 comma c. And c is negative 5. So 0, negative 5. 1, 2, 3, 4, 5 down here, negative 5. Oh, and then a in this case is negative 1, which is less than 0, so I want you to put a less than here. So that means it's doing what? Frowning. It's frowning. Again, you look at the vertex, and it's got to go down or it can't cross it, right? Can't work that unless it does that. So now let's graph this. Let's see. Again, this is going to be tricky to try to get all this to fit just right. And I missed. Let's try it again. That actually probably wasn't very bad. And then it's going to do the same thing, kind of curl it and kind of come down here. Oh, let's see. Also, I know this is 3 units away, so I can come 3 units over here and mark this. So I'm going to mark this over here just so I kind of give myself a point of reference to kind of make it even. And there it is. And so smooth curve there, gets wider and wider forever, doesn't loop over itself. It's not a V, all right? So there is the graph of that parabola. And I did miss a little bit up here, but I mean, it's a sketch. I'm not going to, that's something I would not count off for there, all right? Especially getting the rest of that stuff there. All right, find the information and the graph the following. So here it's in a different form. It's not A. So this is, remember, x minus h. So then h and k. What is h? H is 2. K is 7. And remember, x equals h is the axis of symmetry, and the vertex is 2. It's h comma k. So x equals 2. And they don't have to be positive. The ones I did here so far have been positive. So let's keep going here. Let's see. The vertex is just h comma k, right? It's just h comma k. We got the h and the k in there, 2, 7. So it's way up here at 7. And then let's keep going here and let's see what else we have here. The y-intercept is 0 comma whatever, but this time I can't just look at it and tell. So I'm going to have to do k of 0, which is going to be negative 0 minus 2 squared plus 7. So that's going to be negative of negative 2 squared plus 7. So negative 4 plus 7, and that is a positive 3. So 0, 3, 0, 3. For my y-intercept, let's see, here's A. A is the thing out front. So I do need to identify that somewhere. A is equal to negative 1, which is less than 0. So put a less than, it's frowning. And then we're going to graph it. So it does something like that. And again, 2 units out is going to go through this point, kind of as a point of reference. Like that. So there's my, and let me make that arrow a little better. All right, so there's my parabola right there. Okay, there's my parabola right there. So I hope this helps you when you have to graph quadratic functions.